Hi everybody, Patrick here from Engineering Shock Electronics, engineeringshock.com. This is the second video for the ES6937 motion sensing swivel disc, currently on Kickstarter. The link is below. Anyway, we're going to talk about the code and then we're going to look at the output. If you haven't already, there is a setup video. I'll link that below as well. And so this program builds off the Getting Started program, which was our first video. So if you haven't already checked that one out, I'll link it below too. So we've added some stuff here. I won't go over a lot of the old stuff. That's for the first video. But we've added a couple more integers. State and counter. Hold we created in the first video. And we're also going to use the built-in LED, which is on GPIO 13. And anyway, so in the setup, we do pretty much what we did before. We set up serial begin to 9600 so we can use our serial plotter. A3 is set to an output, so that'll be our ground. For our swivel disc, A1 will be set as an output as well. We'll set that high, so it'll be our power supply. We'll declare our LED as an output. We'll write A3 to low, so it'll be our ground. We'll write A3 to high, or A1 to high, and then we're done with our void setup. As you can see, everything's fully commented. I'm breezing through that because we've already been there with the first video. So in our void loop, some of what we have here is the same. But what we want to do is we want to wait for the output of the motion sensor to become stable before we write to the serial plotter. And as I mentioned in the first video, when you power this thing up, any motion sensor, any PIR motion sensor, passive infrared motion sensor, the output will be wonky and unstable when you first power it up, and we need to wait for it to become stable before we actually want to see the accurate output of it. So we're going to call a function called stabilizer, and that is what we'll be talking about below. But after that, once the code returns from that function, we'll set the LED to high. We'll turn the LED on, and that means that the output is stable. And from there, we'll set state to 0, and we'll do the following while state equals 0. We'll take a reading of analog pin 2, which is the output of the disk, place the result in hold, and we'll serial print ln the value of hold every 10 seconds or every 10 milliseconds. And because state never changes from 0 to 1 or anything else, this part of the code will loop forever until you power down. However, before that happens, we have to run through the stabilizer code. And in stabilizer, we set state and counter to 0, and we'll do the following while state equals 0. We'll exit this while loop when state becomes 1 or any other value than 0. So since there's a delay of 10 milliseconds, then we'll take a reading of the A2 pin, place the result in hold. If hold is greater than 200 and less than 600, the output is considered stable. And we'll add a value to counter. So counter plus plus equals counter plus 1. So if counter was previously 0, counter now equals 1, as long as the analog value is higher than 200 and less than 600. Now, we should really be 300 and 500, but for the sake of this video, let's just leave it at 200 and 600. Otherwise, counter equals 0. So if that value was not within the range of 200 to 600, then we're going to set counter to 0. So even if we do get, many samples where the criteria is met, where we've incremented, so we've got 10 samples in a row, counter might equal 10, because we've had that threshold met 10 times in a row, but as soon as it's not met, counter is reset to 0. So below that we see if counter equals 300, state equals 1, which means we can exit from this function. So the idea here is we need 300 consecutive samples where hold is greater than 200 and less than 600. Otherwise, even if we make it to 299 samples, if that 300th sample does not meet the hold criteria, where hold has to be more than 200 and less than 600, then counter will be reset to 0. We need 300 consecutive samples to be within that window for us to consider the output stable. So as soon as that counter equals 300 consecutive samples in a row, we'll set state to 1, which will end the while loop and will end this function. And then we will return back up to the top. We'll turn on the LED, digital write LED high, set state back to 0, and we'll do the following over and over and over again while state equals 0. So let's see it in action. I need to upload it. Uploaded. Now, because it's already been powered up, the stabilization won't take too long, but the LED is currently off. Let's go to serial plotter. Sorry, I'll reset it one more time. Serial plotter under tools. And what's going to happen is nothing's going to happen until the output is stable. The LED is currently off on my Arduino Uno, the built-in LED, sorry, and we're just going to wait. Now it's on, and we are stable. We're in and around 400. So if you haven't already seen the first video, we talk about the output and what this represents. As you can see, the scale on the left is quite stable, but then we're getting an analog value between 396 to 404 or 408. So that's just room noise. So as soon as I put my hand in front of the sensor, we get a huge swing. We've gone up to 800 almost and down to 200 almost, and then it stabilizes again. So let me do three swipes with my hand. 2, 3. So in the first video when we powered up, there was no stabilization. It just showed us the output, which was usually stuck at 0 volts or 0 volts or a value of 800 where the sensor saturates. You really do have to watch the first video to really understand what we're seeing right now, but we have a very, very stable output right now being sampled every 10 milliseconds. I'll swipe my hand in front of the sensor again. And if you haven't already seen it, there's also a video of me testing this out on my dog. I've got a medium-sized dog, and she sets off the sensor quite well, because it's really detecting the heat coming from our bodies. It's not detecting motion of inanimate objects, it's detecting heat. So that's video 2. In the next video, what we'll do is we're not only going to stabilize, we're going to create a window comparator, which allows for us to then create a sensitivity level that we want to trip an action. Now, when that action trips, what happens next is completely up to you. But I'm going to show you how to create a window comparator using software, and that will allow for us to create our sensitivity limits, high and low, and trigger an action. So again, before I end the video, I'll trigger one more time. 1, 2, 3, 4, and 5. And then, of course, the output will become stable again. Thanks for watching. Check out the videos below if you have any interest, and also the Kickstarter campaign is linked below. Your support is always very, very much appreciated and welcome there if you have any interest. Take care, everyone.